6. To unmute, press.
All right, let's go ahead and get started. Real quick before I hand you off to Bill, if you have any questions throughout the course of the webcast today, most of you are on the audio broadcast, so you will not be able to ask verbally. Please use the Q&A feature right in the WebEx. If you don't see the question and answer box in the lower right of your screen, please hit the question mark in the upper right, and it will open up for you. Please feel free to ask your questions along the way, but I believe Bill will answer them at the end. And if there's anything that we miss, we will make sure we get an answer for you after the session's over. So with that, I'll hand you off to Bill. Take it away, Bill.
Super. Thank you, Len. Good day, everyone. Welcome. Thank you for joining me for this Part 2 session on CA7 performance analysis. In usual disclaimer, informational purposes only. In the session today, I'm going to very briefly, quickly run through the session objectives and disclaimers again that I did in the Part 1 for anyone who may not have viewed Part 1 yet, and also just as a refresher. And then I'll go through various areas around the main CA7 ONL task, and subtasks within that, the various functions, general system subtasks, schedule scan processing, job entries into queues, job submission, job completion, and so on. So we've got a fair bit to work through today, so I'll get cracking. First of all, objectives. What are we trying to do here? Basically trying to provide you with a means, mechanism of doing some initial analysis of your CA7 environment to see if you have areas that can be impacting the performance of your CA7 system, and to highlight areas that might want some more in-depth analysis, maybe from CA services or something of that nature. All of what we're talking about today is based on using existing standard CA7 some reports and or command output. As I've mentioned in Part 1, what I'm doing is building a performance analysis toolkit. It's about 50% built. Some people are out there testing it at the moment. And what it does is basically process the data and provide you with hopefully meaningful graphs, auto-generate them from the base reports, which will help simplify the analysis. This is not a magic wand. Basically, what I'm trying to do is give you information which may or may not be relevant to your site or the way you operate CA7. Any areas that the toolkit or the graphs that we produce highlight or identify may only, even if you do some changes, adjustings, they may only give you minimal or even no performance gains in your particular environment. So it's very much as a try it and see type basis. Any of the code that I'm providing is written by me and is provided on a strictly as-is basis. It's not a CA product. It's not supported by CA. I will support it and carry on updating it and maintaining it. And they may not work in everyone's environment. Certainly I've had a few customers come back and say, at the moment the version runs uses Rex on Windows, and some customers say they can't run Rex. I am producing a ZOS version where the Rex runs on the mainframe. That's not quite ready yet. It's all of this is for reporting purposes. None of the functions that are included do any fixes or changes to your system in any shape or form. It's purely for you to identify information. So with that said, very quickly, let's go in now and start looking at the system. And a good place to start is basically with the main subtasks, and we'll go into more detail on each of those in terms of things like schedule scan and prompt processing and the job queues and the way you load jobs into those queues and how we handle submission and so on. But initially, what we're going to start off with is a look into the main subtasks to give you an idea from a summary, high-level point of view, how well the various different subtasks are doing, whether you have any anomalies in terms of high activity on certain days in particular parts of the subtasks that are going on. The graphs that are available or that I'm using for this range from 320 actually up to 400. I've got a slight error there. And there are a variety of different numbers. And as you'll see in the output, the graph numbers information. What I'm trying to do is put them into a column, collect the information that's available across all of these APA graphs into a single view, so you can compare the data day by day for each of the various subtasks. We can then look at it in more detail through the EX or EasyTree or EARL report number 36 to get a lot more detail. Initially, here's our performance report 36, in this case EARL version ER036. As you can see, it gives you lots of information, but it's not necessarily easy to understand in that format. So what we try and do is produce it in a format that is much more easy to understand. This is taken from the APA graphs. As you can see, the numbers are listed at the top there, 320, 330, 340, 350, 370, and 400. And we've taken all of those, put them together, and produced a single graph doing a comparison. And from this, you can see whether or not you have roughly the same amount of processing time associated with on each particular day of the week. And in most cases, in the sample data here, the amount of percentage of CA7 CPU time used for each of the subtasks is around the same, with the exception of one in the middle there, which is day 224, where you can see that the prompting orange color is quite thick in compared to a thin amount for most of the other days. So that's something that maybe you would want to look at if you get that sort of difference in time taken for a particular function. The orange is prompting, the light blue at the bottom is your scheduled scan processing, and again, on that same day, there was more scheduled scan activity, so both of those things could lead us into looking at what's going on around the prompting, which could impact submission of jobs and so on. From the 36, the EARL EasyTree report number 36, we can actually break this down into hourly information. And what I've done with this particular graph is taking that hourly data and averaged it over the month's worth of information that I'm processing. and so we get the average value for each of the different tasks through each hour of the day, from midnight through to 11 p.m. And again, what we're looking for is to see if there are any periods in a day, on average, where the amount of time taken to do one or other of the subtask processing functions, submission or job loading or prompting and so on, is unusually different for that particular hour. Again, 9 o'clock in the evening, the third from the right one, prompting is quite high in comparison to most of the other hours of the day. So that gives us a brief look at the various tasks as a summary overall view within CA7. And then what I'm now going to do is take each of those areas and drill down and look at them in a bit more detail. So first of all, scheduled scan processing. The scheduled scan processing, time analysis, the whole processing activity that we consider to be scheduled scan includes things like selection scanning for jobs, which is what you think of scheduled scan actually being. It's the process of scanning your database to see if there are any jobs to be submitted or to be loaded into the request queue, shall I say, based on their scheduled definitions. But as part of what CA7 considers to be the scheduled scan activity, we also include a job loading process for those jobs that we select. They're included in the overall task time. All the prompting, all the late job processing, looking for jobs that are late and reevaluating them on a regular basis. Associated with the late jobs could be prompting. That does depend on your init deck option of reprompt. But often, if you have late jobs, you'll generally have prompting turned on, which is generally not necessarily a good thing. We'll talk about that in a short while. Also, for jobs that go into skeleton status, when they get loaded into the queue, the scheduled scan processing, per se, the activity includes doing retry processing for that. And also, for XP jobs or cross-platform jobs, there is a resubmission retry for XP jobs. And again, that's based on your XP retry init deck option. So what we really want to do here is compare scheduled scan activity, all of it in various stages, with the number of jobs in the queue. So, if on a daily basis your average number of jobs is about the same, you would expect scheduled scan processing to roughly be the same. If there are differences in your queue, number of jobs in the queue on a daily basis, then you would expect to see differences in scheduled scan processing. So initially, we have a look at the scheduled scan, the whole time of the scheduled scan processing, including all of those functions and so on and so forth that I talked about, and we look at it on a total amount per day across the period that we're doing the analysis for. And that sort of scheduled scan graph should match fairly closely with the number of jobs that are being processed through scheduled scan and reprompts and so on. If you have unusually high peaks that don't match with your number of jobs for that particular day, then some of the other activity within the scheduled scan total processing may be causing a problem. You can generally, from these sort of graphs, see when weekends are, the number of jobs drops, therefore the amount of scheduled scan activity tends to drop, so you get a lower value over the weekends and higher values in the middle of the week, and maybe days like Fridays and so on could be worse, So here we can see scheduled scan compared to scheduled scan processing time compared to the number of jobs loaded through scheduled scan on a total basis per day. And there are ups and downs, and they generally match on the same days that you have ups and downs in schedule scan processing time. However, there are, for example, in the middle, quite high peaks of schedule scan time when there are no equivalent high peaks of jobs. So this is an indicator that something else is going on that we may need to look at. So now we start looking at using various different NPA graphs. We can drill down into the components that make up the schedule scan processing, the various pieces that I talked about. So you have your actual job scan function that reads the database and selects jobs to be brought in. We have prompting time, and we have job load time. Now, in this example data here, our job load time, which is the grey bit at the top of each of the columns, is actually fairly small. So that tends to indicate that there is not a huge amount of problems with actually loading the job in, reading the JTL, and so on and so forth. However, there's quite a significant amount of time, especially on day 224, where we have a fairly high amount of time for prompt processing. And there is, across all of the days, there's quite a big chunk of prompt processing going on, with certain days being considerably higher than others. This tends to indicate that there are a lot of late jobs, and this may be something that needs to be looked at. We can also look at scheduled scan times based on the amount of time per wake up during the day. So how much activity is going on each time the scheduled scan wakes up to do a scan of the database, do the reprompt, do the late job checking and load jobs in, that it selects and that sort of stuff. How long does it take per time it wakes up as an average across each of the days? And that's also quite interesting to look at. And again, you tend to be able to identify lower periods of activity, weekends and so on, by the fact that the amount of time taken is much less for those days per wake up, because there's not as much work to process, and probably less prompting going on, less job loading going on, and so on and so forth. So we saw that in that example data, we saw one of the days had a fairly high prompt value, and this is set in the init deck, how often you do reprompting. It's on the schedule statement. There's a reprompt parameter in minutes from 0 to 60, with most sites setting the value to be 30 minutes. The question I tend to ask then is actually, do you do anything with those messages about late jobs? A lot of sites have due out times set on jobs that were set up 15 years ago, never got around to maintaining those due out times, so they expect lots of jobs to go into late status and generally ignore any messages that come out relating to late jobs, because they know the due out times associated with these jobs are not actually accurate at this moment in time. So what you need to ask yourself is, well, if I have a lot of late jobs and I generally tend to ignore late job messages, maybe I ought to just turn off the reprompting or the prompting function. That will save you a fair amount of overhead in the actual scheduled scan processing. If you turn off late prompting, set reprompt equal to 0, and that will then get rid of that particular amount of overhead. Whether it's a benefit or not is down to how many late jobs you have. So you may want to have a look at, is it worthwhile if I only get 5 late jobs a day? We can look at the activity of the prompt task by itself in detail, select that particular graph, and as I said there, from this you can now more clearly see that day 224 and to some extent day 223 had much higher levels of prompting than most of the rest of the days in this particular sample data of month data. So that's something that would be definitely worth looking at, and have a look at, for that day, what are the late jobs? How many late jobs did we have? And on day 224, we hit up to 2,000. But equally, which is interesting, is that there are a number of other days when we had similar numbers of late jobs, 1,900, 1,800 and something, and yet if we go back to the prompt task, we don't seem to get the same sort of level of prompting going on. So it may be that on that particular day, 224, not only were the late jobs, but they sat in the late status for a lot longer than is normal for most other days. And that may have been because of a particular issue on that day, or maybe that this is a general problem on that day of the month or something of that nature. There may be applications that are running on that day that don't run on other days, that have a lot more late jobs, or have late jobs that wait and be late for a lot longer, which obviously means you will get more prompts for jobs that are sitting in late much longer. You can also break it down using the L job with the late equal value for particular days. Break it down by how many jobs were late by system name. Okay? In this case, I've sub-selected on late jobs where the number of jobs in a system name exceeds 100. So if you have more than 100 late jobs, they'll be included. You may want to increase that. If you have a lot of late jobs, set the minimum count to 500 or something. But you can now start to do some analysis about which applications or which systems are being late or having more late jobs, and maybe then start doing some investigation around those applications, determining why are we getting so many late jobs. It might be just because they have lots of due out times, like we said, as I said, many years ago, and are no longer accurate. So it may be worth looking at either getting rid of due out times or turning off reprompting and so on. Let's have a look now at the queues, job entry into queues. How do we get our jobs into the queues? In terms of CA7 recommended best practices and for the best performance of CA7, then the recommendation is always to have as many jobs triggered or the majority of your jobs brought in by trigger processing. We tend to recommend not more than 20% of your jobs are actually scheduled through calendar schedule definitions. And you can look at, use the information in reports to view and see the comparison of scheduled, triggered and demanded job counts as a percentage per day, and also as an average value hour by hour throughout a day. The hourly average will then give you some idea into what are your peak periods in terms of processing. You may already be aware of that, but if you're not, then this gives you some insight onto when is the busiest time of day generally in your CA7 system, and maybe give you some thoughts about, well, is there, especially if you have very big peak periods, is there a way we can adjust some of our scheduling to reduce the peaks? So here we have a view on a day-by-day basis for the period in question using various APA graphs. You can see the percentage of jobs that are scheduled, triggered, triggered by jobs, triggered by data sets, and demanded. This particular sample data I have shows a very good system where a very small amount, less than 10% per day, are being scheduled. The majority are being job triggered. A number are being data set triggered, and a few, a small percentage, 4 or 5%, are demanded in through, either through automation or through manual activity. So this is actually a fairly good view of well within the recommended best practices for loading jobs into queues. We can also look at this on an hourly basis, although the triggered jobs we don't separate on an hourly basis. We don't distinguish between job-triggered jobs and dataset-triggered jobs. They're all just triggers. But again, you can see that the spread of work is mostly even for schedule, processing, and triggering, with a slight increase in scheduled jobs in the 4 a.m. period or 3 a.m. to 4 a.m. period, and the 8 p.m. to 9 p.m. period. They're slightly higher values of schedule, but that's perfectly normal or perfectly in line generally with scheduling requirements. There is a higher number of jobs at that time of day, for example, in the particular site. If you use this information, you may find you have different peak times. What we look at then as part of the queue entry processing is what we call dwell time. Dwell time analysis. There's dwell time in various different processes, and we'll talk about dwell time a bit more. But in this particular case, the dwell time we're talking about is the total time it takes to load a job into the request queue when it's been selected. And there are several processes that are going on here. You've got to obviously add a job entry into the request queue. You've got to create a trailer queue entry to store predecessor information, dependency requirements, and so on. The system has to allocate to the JCL library. You have to open the member, read in the job JCL from whichever library number is being processed. It then will process through any JCL override cards that you might have. How many you have could impact your dwell time. Things like #JI, #JO with #JN combinations, or #ARF, #held, #non-executable, #STC, and so on and so forth. And then it has to store that JCL in the trailer queue entry that was created early on in the process. So as you can see, when we talk about job load, we're talking about quite a number of different things that are going on, and we can start to look at some of those areas in a bit more detail. One of the things that can impact on the dwell time for loading jobs, how long it takes to load jobs into the request queue, is your use of override cards in the JCL, because they have to be processed during that job load thing. And what we've got here is a comparison of total number of jobs per day compared to how many of those jobs have JCL overrides. So we're looking at roughly about 8 or 9% of the jobs at this particular site. 8 or 9% of the jobs use override cards. Maybe perfectly valid, or maybe things that, well, do I actually need all of those cards in there? That's something, again, to look at. And so we can then take a view of what's the average dwell time per job across the hours of the day. Okay? So we're looking at hours of the day, and for each job, how much time on average does it take to load a job at different hours of the day? you can see ups and downs. That could be for a variety of different reasons. For example, the number of jobs using override cards may be higher at certain times of the day. There may be a bit more contention against the disks that have the JCL libraries on. The trailer queue may be busier at certain times of the day, so it takes a little bit longer to load the JCL and so on into the trailer queue. There may be more JCL to be loaded at jobs running at certain times of the day. So there's a number of different factors that may impact how much time it takes to load a job, but it gives you a good view across the hours of the day about how much time on average it takes to load a job into the queues. What we then look at is job submission. So we've got the jobs in the queue. We now need to go through this job selection for submission analysis. And again, job submission isn't just a single thing. It does lots and lots of stuff. So, for example, first of all, it will scan jobs in the ready queue to pick up anything that has a master count of 0, i.e. they have no requirements anymore, so they are can be moved into the ready queue. It then has to scan the ready queue and evaluate jobs for readiness, and that includes things like workload balancing and virtual resource analysis. And then it invokes the actual submit processor, especially if you use a parallel submit processor, to actually send that JCL or submit that job's JCL to JES. There are a couple of options, or the JSOP options on your option statement in the init deck that can impact the overhead that the schedule scan processing takes. If you run with 2, 3, 2 says that schedule scan processing or submit processing will carry on independently of job tracking. If you don't have the option 2 there, then they will interleave. You'll have tracking followed by submission, tracking followed by submission. The 3 option refers to submission analysis based on longest time in the queue. How long has the job been in the ready queue? So that again is a bigger overhead because it has to evaluate when it's doing the job selection for submission, which ones have been waiting the longest before it actually decides can it submit it. And then it may be hit by workload balancing and virtual resource management requirements that stop it actually submitting that job. So the 2, 3 can impact your overhead. So first of all, we look at the submission time on a day-by-day basis. This is the amount of time the submit task is active in comparison to CA7 as a whole, across the whole total value across all of the days of the period. What we can also look at from one of the SASIS 8 reports, HR22, is the jobs not submitted. And what we're counting here is the total number of times jobs were not submitted. We're not looking at the number of jobs that were submitted, but how many times were all of the jobs that were not submitted passed over for various reasons. They're in the ready queue. So there are no dependency requirements, anything or time requirements. And what we're talking about here is purely job submission evaluation for workload balancing and virtual resource management. And as you can see, certainly on the 3rd day of this particular month, day 215, there were over 3 million retries for submission, or 3 million times that jobs were bypassed and not submitted for whatever reason. That's a fairly big number. And what you want to do is look at these reports, certainly the job not submitted report, and say, why was it not submitted? How, what was the reason behind it? So we can start then to break it down. So there are SASIS 8 report HR22 will provide you with the detail about what type of thing was used or was causing the jobs to not be submitted. We get a total value for workload balancing, and we get a total value for VRF. That's the blue and the orange. So on day 215, for example, there were a lot of not submitted because of VRM reasons. Whereas most of the other days, it tends to be, in this sample here, it tends to be workload balancing that is causing the problem. And you can see, certainly later on in the month, there's a huge peak of not submitted through workload balancing on day 232, where we were up at nearly 2.5 million non-submissions during the day. Now remember, each time we have a non-submission, that's an overhead on the system. The system has to reevaluate that job again because it wasn't submitted last time the submit processing scan activity went on. So reducing the amount of time jobs are not submitted can improve the performance of your system. We can look at this and say, well, how many jobs were not submitted one or more times per day? So this is the actual total number of jobs that were not submitted at least once, as opposed to the previous value, which was the total number of times all of the jobs were not submitted. So on a day-by-day basis, we can see that jobs were not being submitted were particularly high on day 217. We had over 3,000. Day 231, where we were again up at 3,500 and so on. So maybe good reasons for that, or it may indicate some issue with virtual resources or with workload balancing on those particular days. We can now look at it and break it down a little bit more. The main reasons for non-submission are workload balancing class barriers and workload balancing priority usage. And on the VRM side, co-requisite resources, exclusive resources, or resource counts. And as you can see for this, the majority of, over this period, the reason for not submitting was WLB class barriers. So if you're using workload balancing, have you got class barriers set? Are they too low? Are they impacting on the submission of jobs? Is there a reason for using class barriers? These are all questions that you need to ask yourself. The other values, priority and virtual resources, are fairly low, but again, could be an impact. We can then take that same data and just compare it on a day-by-day basis. So in this case, we're looking at workload balancing, the class and the priority. On a day-by-day basis over the period, as you can see, the majority of it was class-related, although there were a few peaks when you had priority-related delays to job submission. And we can do the same for virtual resources. We can look at virtual resources by resource count, co-requisite resources, and exclusive. As you can see, co-requisite and exclusive were pretty small. Showed that in the previous overall summary graph. Here you can see it in a lot more detail. The majority of virtual resource reasons are because of resource count values. So it's waiting for an RCT type virtual resource that isn't available. Again, you question or you need to review and look at if, is that a resource that's actually required? Is there a reason for it? And so on. Again, because of the impact it may have on submission. So we talked about actual job submission activity, but there are some processing phases that submission will go through when it actually gets around and selects that job to be submitted. So we've got past workload balancing, we've got past virtual resources. We now need to actually submit that, and it goes through a series of processing. There's pre-processing, so we have a disk dwell time. This is when the JCL is being brought from the trailer queue. We open the driver library if you're using CA driver deprocs, and we process include, exclude cards that happen at submission time, as opposed to the JI ones that happen at job load time. From there, we then go into the actual processing of that. We'll process the driver procedures, we'll resolve global variables in the mod dwell and the prop dwell, and we then write that modified JCL out to the internal reader. And then once we've written that out, we then have to, we have some post-processing to do to clean up. We have to end the interface, the driver interface, close the library. We need to update the ready queue to say we've submitted the job, generate some submitted messages, and if we go through a not submitted process, then we got, you know, a resource release and a job requeue activity to take place. And again, we can look at that from a Status 8 report, HR24. We can break that down into disk dwell, mod dwell, prop dwell, and post dwell time. And as you can see, the prop dwell, which is the bit to do with driver procedure execution and global variable resolving and writing to the JCL internal reader, is generally the highest activity within all of those. Now, one of the things that the prop phase that may be causing a high activity on the prop phase is the fact that during the processing phase, there's a request for a submit processor. So this is the actual piece of code that writes the JCL out to the internal reader. There may be times when, if you have a busy period when lots of jobs are being submitted, there may be times when a job goes into the processing phase and has to wait for a submit processor to be available, a task to be available to actually submit the JCL through to the internal reader. And our HR24 report provides select dwell time as well as busy and retry count. So how many times did the system retry to get a submit processor to actually write that job out to an internal reader? If you're using PSP, parallel submission, you may want to, if you get a lot of high busy retry counts, then you may want to have a look at your settings on PSP. And compare all of this information with your number of jobs being submitted, busy periods, peak periods of the day. And in this particular example, submit task busy dwell time on an hour-by-hour basis shows a huge amount of select dwell time at midnight to 1 a.m. compared to the other hours of the day. So again, this is something that you may want to look at in a bit more detail. Similarly, when we go into a busy state, i.e. there's no submit processor available, we're in select busy, and this is the retry count. And as you can see, the retry count at that period of the day, from midnight to 1 a.m. Is very high, up to 5,500 retries to submit a job. And now this could be purely because there is just such a large amount of jobs being submitted at that particular time of the day, or it could indicate that there are some issues with selection and submission. Then get into job completion. I'm conscious of the time here. So this is all about SMF feedback, COMMDS processing of records, and job completion within CA7 itself. So we've got a COMM task that will read the SMF records from the COMMDS. So again, we need to look at activity of the COMMDS and busy conditions. We then have the SMF task processor that processes those records read from the COMMDS and does the update to the status of jobs. And then when jobs go into complete status, we've got a job end SMF record. We have a job completion task that updates queues and does trigger processing and so on. And again, each of these you look at and compare with your job completion counts on an hour-by-hour, day-by-day basis. So here we have total amount of time taken by COMMDS read processing, the COMM task, which is purely does nothing but read the data from the COMMDS and make it available for the SMF processor. And again, as expected, there are peaks and troughs. Generally, the troughs relate to Saturdays and Sundays, where the peaks are more work days. We can also look at comparison of read and busy conditions. With the COMMDS, when you have ICOM collecting SMF data and writing it to the COMMDS, every time it does a write to a COMMDS, it locks the COMMDS. It has to in order to not have an update clash with another ICOM going on. So during that lock period, which is generally very small, the COMMDS is classed as busy, and CA7 can't actually read it. And there are, in one of the graphs, 750 APA graph, there is a value of the amount of times that CA7 found the COMMDS was locked out, it was busy, couldn't get access to it. And generally, you want that to be fairly small, and as you can see from the sample here, compared with the number of reads, the busy conditions are a very small percentage. So this is good. If you have a high percentage of busy conditions, then you may want to look at your COMMDS, how many ICOMs have you got writing data to it, and maybe do some evaluation of performance of that data set. SMF task, this is the task processing the SMF data. Again, we're looking at it for unusual peaks, but you need to compare this with the number of jobs you're processing, how many jobs are completed, or generating SMF data and so on, because obviously the amount of SMF being processed will depend on how much is being generated. And you tend to compare those two together, job completion task time with SMF processing, and if I flick back and forth between them, you can see that the peaks and troughs match up fairly well, and that tends to be expected. And again, you then look at it with how many jobs do we actually have completed on a day-by-day basis, and the total. Again, if you look at those in comparison, you'll see that they are fairly similar in terms of the overall view. Final area is user transactions. I'm going to go through this fairly quickly. Transaction processing is all about handling input and activity requested through any type of terminal. Okay? And the priority that CA7 responds to transaction requests depends on the order of the definitions in your init deck. Okay? You should always have your console group line and term definition first, followed by the VTAM virtual terminals that people are using 3270 or through the web client, both of which use the VTAM virtual terminal numbers. So your group line and term definitions for the VTAM virtual terminals should immediately follow from the consoles. Look at your init deck to see if that's true. Following that, then, there are a number of other terminals, and this tends to be the recommended way or the recommended order for response time or for priority of response for these. So your CCI device, group line and term definitions next after VTAM virtual terminals, and that covers both CCI and TCP/IP terminal interfaces. Then you have your TRX-DB, which are related to ARF, automatic recovery facility activities, and anything coming in from the XPS server, cross-platform scheduling server. Then trailer device, that's used by the trailer sets, and at the bottom your batch devices used by BTI jobs. Generally BTI jobs need a lower priority than online terminals and CTI terminals that are wanting a response. You can look at overall terminal transaction responses, what's the total, how many we have going on per day. This includes everything, all types of transactions, and as you can see, on certain days of the week through this month, there are fairly high peak terminal activities. Now, generally, end user, people on 3270s, don't change their habits that much, certainly not on a regular basis. So this would indicate that there is high activity through either BTI or CCI, TCP/IP terminals on those particular days. So again, that might be worth looking at. What are you running? If you get a peak like that, what are you running on those days that causes such a difference in the amount of transactions going on through CA7? You can also look at it from a response time, transaction response time. So we have time of transactions less than 3 seconds compared to the total. And as you can see, they virtually match identically, the blue and the orange. And that means that in the main, probably 99% of or higher of all transactions were responded to by CA7 in less than 3 seconds. That's good. Okay, it's where you get transactions that were responded to greater than 3 seconds, and whilst these graphs, the peaks and so on, look high, if you look at the numbers on the left-hand side of the graph, you'll see it actually is a low number count. So, at the peak, we were only having, something like less than 80 transactions through the day, took between 3 and 10 seconds. So you've got 3 to 10 seconds, 10 to 60, and longer than 60. And anything that takes longer than 60 generally refers to BTI terminals and hopefully low priority, and you have a very low number of those. Now, all of the graphs that were in this report are produced or will be produced. Some of them were produced manually initially, but I got fed up of doing this manually at different customer sites. And so I started building a toolkit to help me generate those graphs easier, and then decided to make that available to you guys. So what it does is extract, you run the reports as identified in the documentation. The reports are then downloaded to the PC where you've installed the toolkit, and the performance toolkit will extract the right data from those particular reports, throwing all the headings and everything away, and will automatically then generate the graph view that you see on all the different things using Excel and using your current data, as opposed to the sample data you can see in this presentation. The graphs currently are set up to use Rex on Windows, so you do need to be able to install Regina Rex on a PC. You need to have Excel because it uses Excel macros, and you need to support VB scripts because the whole menu system is driven through scripts. And you get a menu system example here. Pull down menus. The red ones are ones that are not currently finished yet. They're not working yet. The Rex code to do the extract. All of the graphs generation and scripts are done, but the extract of the data through a Rex routine is not completed for the ones that are shown in red. The green ones are the ones that will work. If you are interested, I have a number of customers from part one who emailed me and said, can they have a copy of whatever is working at the moment. I will be producing a version that does not require you to install Windows Rex on your PC. A number of sites have said they're not allowed to install stuff like that on their PC. So I'm producing a ZOS version where all the Rex routines will be run on the mainframe, and instead of downloading the base report, you would download the extracted data, and I'll let you know when that's available. But if you are interested in the version that is PC-based at the moment, then please drop me an email, bill.sherwin@ca.com, or follow me on Twitter, and my handle is @CA7WA_expert. I'll be notifying on Twitter when things are available. There is a package available at the moment with around 16 or 17 graphs that are working at the moment out of the set. So if you want to try that out, feel free to contact me. I am talking with services about trying to offer this as a more in-depth service. Thank you very much for your time. I'm now open for questions, if there are any, in the Q&A session.
Hey, Bill. Great session as always. No, we don't have any questions at this moment. For those of you who are on the call, if you have any questions for us, please use the Q&A box right in your screen. We'll give you a minute or two to type your questions. I know we are close to the top of the hour. But if you have any questions, please feel free. And if you have any questions that pop into your mind after we wrap up, please feel free to go out to the community if you don't want to email Bill directly.
Yeah, you can always email me directly if you've got any questions.
Sure. So I don't see any questions coming in, so I guess we can probably wrap up for the day. Bill, thank you very much. And also thank you to all of our attendees. Hopefully you found today informative and valuable. So have a great day, everybody.
And thank you, everyone. Bye-bye.